Hey there. Thanks so much for joining us today on the Verbal Essay Podcast. I'm delighted to dive into some cutting-edge research that's reshaping how we fine-tune large language models at test time. Our spotlight today is on a fascinating study from ETH Zürich titled Efficiently Learning at Test Time: Active Fine-Tuning of LLMs. Now, traditionally, when we train machine learning models, there's a clear separation between the training phase and the testing phase. You train your model on a vast dataset to generalize well, and then you test it on new, unseen data. But what if we blur those lines? What if, at test time, we fine-tune our models specifically for the task at hand? This is where the ETH Zürich team steps in with their innovative approach. The researchers identified a significant bottleneck in the current methodologies used for fine-tuning language models. Typically, fine-tuning relies on nearest neighbor retrieval from large datasets to select data. However, this method often leads to the selection of redundant information, which can hamper the model's performance rather than enhance it. Imagine trying to study for an exam by reading the same chapter repeatedly instead of covering all the material. You wouldn't absorb much new information, right? Enter SIFT, the star of today's discussion. SIFT stands for a sophisticated data selection algorithm designed to minimize uncertainty about a model's responses to specific prompts. Unlike nearest neighbor retrieval, which tends to pick similar and potentially repetitive data, SIFT intelligently selects diverse and informative examples. This approach not only reduces redundancy, but also optimizes the overall information gained from the selected data. One of the standout aspects of SIFT is its foundation in active learning principles. Active learning emphasizes selecting the most informative data points to learn from, ensuring that each piece of data contributes uniquely to the model's understanding. By merging these principles with retrieval methods, SIFT strikes a balance between relevance and diversity, ensuring that the fine-tuning process is both efficient and effective. The empirical results from their studies are quite compelling. When evaluated on the PILE dataset, a comprehensive benchmark for language models, SIFT consistently outperformed traditional nearest neighbor retrieval methods. Not only did it achieve better performance, but it also did so with minimal computational overhead. This is crucial because in real-world applications, computational resources are often limited, and efficiency can make or break the feasibility of deploying such models at scale. Moreover, SIFT's ability to estimate uncertainty about model responses adds another layer of sophistication. By predicting the performance gains from fine-tuning, SIFT can adaptively allocate computational resources where they're most needed. This adaptive investment ensures that we're not just throwing data at the model haphazardly, but are strategically enhancing its capabilities based on informed predictions. The implications of this research are far-reaching. By improving the effectiveness of test-time fine-tuning, SIFT opens doors to more dynamic and responsive language models. Imagine having models that can quickly adapt to specific tasks or domains on the fly, enhancing their performance without the need for extensive retraining. This could revolutionize applications ranging from personalized assistance to specialized research tools. Looking ahead, the ETH Zürich team envisions several exciting avenues for future research. One potential direction is grounding models on trusted datasets, which could help mitigate biases inherent in the training data. Another is dynamically incorporating private data, ensuring that models can adapt to sensitive information without compromising privacy. Additionally, extending these principles to other model architectures, such as diffusion models, could further broaden the applicability of SIFT. In conclusion, efficiently learning at test time, active fine-tuning of LLMs presents a significant advancement in how we approach fine-tuning large language models. By addressing the limitations of traditional data selection methods and introducing the innovative SIFT algorithm, the researchers have paved the way for more efficient, adaptive, and high-performing models. As we continue to harness the power of these advancements, the future of machine learning looks not only brighter, but also smarter. Thanks for tuning in today. Stay curious, and until next time, keep exploring the fascinating world of knowledge.